So welcome everyone to what's probably going to be the most depressing session of this conference. I thought it might make sense for us to get this over with quickly, so let's get this up front. Most of the architectures I'll be talking about aren't good enough. I tried my best to find some that were, but I ended up finding so many that I found interesting that really have some problems, or some challenges, or some issues. So to protect the innocent, none of this, of course, applies to any of you, right? None of you have ever done anything similar to any of the catastrophes that I'll be talking about. And I also tried to end on a positive note with a few positive things. So the thing I want to talk about is situations where architecture either was too sophisticated or not sophisticated enough, where it missed hitting the sweet spot. Now, architecture is to some people a little bit of an insult, right? If you label somebody that he's just mostly he, sadly, he's just an architect, that's like saying, well, he doesn't really know what he's talking about. And he just, creates big pictures that sit on some wall and only they themselves ever look at, nobody else, because nobody cares about what they do. I don't subscribe to that view of architecture. Does anybody else in this room self-identify as an architect? Does anybody do that? Oh, very slowly raising a hand. Okay, so these days it's very popular to view architecture as sort of something that everybody does, and I completely agree with that. And we'll get to that point a number of times during the presentation. That because I wanted to start with this, I have a little bit of formal stuff at the beginning, which is actual definitions, right? So you can go from very, very formal to kind of loose, and I want to start with that. So if you look at a very formal definition of what architecture is, and I actually found the ISO standard that defines this, it's the elements that your system is composed of and their relationship, the environment they sit in, and the rules and principles of their design and evolution, right? That's like a very formal kind of thing, but it seems intuitively to sort of make sense, right? It's the important stuff within your system, the important elements that are connected in some way, and somehow that seems to matter a lot to a lot of people who take a look at your system and who have to use or evolve your system. I also like this definition a lot by a gentleman named Grady Booch, which simply says it's whatever hurts if you get it wrong, right? So the amount of decisions that you better get right, which does not mean that you can't change your mind about architectural things. It's just much harder to change your mind about something that's part of your architecture as opposed to something that's just an implementation detail, right? Mostly, though, I find that architecture is basically this, right? It's whatever that person or the people who are involved with, who label themselves architects, consider important enough to merit their attention. And that can be lots of things that shouldn't really be architectural issues, like really small, very, very simple, or very many details about something that really doesn't matter, that should be left to the developer who actually does the actual work to decide, as opposed to somebody who makes a big decision about this thing. And in the same vein, you have a lot of situations where very important things are not being considered by anybody who does this from an architecture perspective. Again, that doesn't have to be a person who's labeled an architect. It can be just somebody, this person today and that person tomorrow, but somebody will make those decisions. It's probably a good idea to make them consciously. Now, let me get this out of the way as well, because some people still think this is the case. I definitely do not think that architecture is just it's a big design upfront activity that you have to do at the beginning and then you're done, right? This is something that I don't think was ever true, but these days you can do a majority vote and 95% of people will agree, even architects, even those who have architect on their business card will agree that this is the case, right? It's not an upfront activity. And a second statement in that line of thought is that architecture is not a description, right? Architecture is it is your system. Your system has an architecture. Doesn't matter whether you want it or not, it just has an architecture. It may be intentional or maybe accidental, but it definitely has an architecture. So it's a property of the system. Now, what's a good architecture? That's a very stupid question, which is sort of the idea with the title, right? To get you a little bit pissed off at me, to start things off in a good way. So this question, what is a good architecture, is similar to asking what's a good car, right? I mean, I really don't know. I mean, is it a matter of taste? Probably as well, but it's also a matter of what you're going to do with that car, right? What is it? What's the purpose that you're looking for, and you'll have to pick something that matches your situation. And again, very formally, there's a quality model, and some other ISO standard gives you a bunch of things that you have to think about if you look at a system. And if you want to assess any architecture, if you want to look at any architectural quality, you always have to take the architecture in relation to the actual quality aspects that you care about. Right? You might care about performance more than about security, or the other way around. You might place a very high value on usability, but not so much on maintainability, or whatever it is. You'll have to figure out what that is. And you can see that in many cases, and you can also see that people, even though this is a very obvious kind of thing, right? This is not rocket science or anything, this should be completely obvious. People miss that all the time. I use this slide a lot when I talk about scaling. If you look at scaling dimensions, you can view different axes here, right? You can talk about logic, the complexity of the system from a business domain perspective, and you can talk about the load, the number of users that this system will have to endure. Right? So if you look at something like this, the scale for load goes from something that serves a dozen users to something that has to scale to half the planet. Right? If you're building something like Facebook, then you have completely different needs than if you build something internally. And the logic goes from something that you can write on a rainy Sunday afternoon to something that incorporates some aspect of German tax law. So it's really a broad range that you have here, right? You can pick a random CMS, maybe that's the easiest thing, right? It's very easy. You could write one yourself, you can use one for simple tasks, and then you can sort of try to put things somewhere. We can argue what belongs where here. I would say that Twitter is not that complex logic-wise. You might disagree, but I think it doesn't do many fancy things, right? It just scales a lot. Facebook does more, I think, sadly. Amazon, I think, doesn't have the scale of Facebook, but a very, very high scale and a lot more complexity. And then you have, like, whatever, your typical insurance policy management system. That's just the hell to implement, but doesn't have to scale this. So there's no good or bad architecture without looking at quality attributes. So with that prologue out of the way, I want to look at some concrete cases, right? At some examples where you can see some things that went wrong when people try to apply those. And the rough structure I use is I look at the context of something and I have some observations and possibly some lessons learned, hopefully at least. So let's look at the first one. This is, I've labeled this non-extensible extensibility, and that was really sort of a very interesting moment for me because I noticed this for the first time when I reviewed this particular project. We had a small team that did that. And we took a look at this particular company and their systems and noticed a pattern that reappeared again and again in a number of situations. And it went like this. So the context is a global e-commerce company, right? A digital service provider of some kind. Doesn't really matter what they do. But the key thing here is the global customer base, and their clients actually use the platform to serve their clients, like something like Shopify, but it's not Shopify. It's much older than that. It provides a lot of features to their clients that they can use to serve their own. So it's multi-tenant, of course, and a key aspect was that it was highly customizable. That was sort of the key idea. It's so super customizable that anybody can use it to incorporate their own special needs, right? So you have different kinds of needs. You have something from very general to very specific, and you have low complexity to high complexity, and you have your or it's actually a cost in building that related to the complexity, and you have a number of different clients. Like you have this super strategic, large customer who really want extremely specific stuff. They're perfectly willing to pay a ton of money, but they have very, very specific needs. And then you have very simple clients, small customers, the sort of long-tail customers. They basically want to change the color of the login screen or maybe upload their logo or something, right? They don't have fancy needs. They also are not willing to invest a lot of money because they don't have much money. Now, if you look at those typical kinds of clients, basically all of the clients that they had could be put in those two buckets. They either were very strategic, large clients with very specific needs and a lot of money, or they were small customers that were in the long tail. And they actually built a system that was perfect for this, which is a very, very sad situation. The solution was customizable. It actually had its own IDE based on Eclipse, right? So you had to download a 150 megabyte package of IDE, which was a lot back then, to get started, and you had to learn this very specific environment to customize the solution, and then you were unhappy, either because it was way too complex or because you couldn't do what you wanted to do. So that was not a good solution. What we actually ended up recommending, and what I think they implemented, I'm not 100% sure, is that they actually build something very specific for the very specific clients out there. Because they pay so much money anyway, it doesn't really matter. You can build an actual program, surprise. As opposed to configuring something, you just build a program that will match their actual needs, which turned out to be a much better solution for this. If you attempt a design that will satisfy everyone, you'll end up satisfying no one. That's exactly what happened to them, right? It matched no one's need. And highly specific stuff is often much preferable to those super configurable solutions that you have somewhere. My next example is what I like to call perilously fine-grained. It's something that you can currently observe in a lot of systems. I'm not pointing fingers here, but you know who you are. So this particular context was a large company, very large multinational company, building a huge system, basically company-wide, replacing many existing systems, many commercial off-the-shelf systems with newly built software. A ton of developers, I think it went up to more than 300 at some point in time, developing in multiple teams, of course. Now, when the system started out, when they started out building that particular system, there was just one company and essentially one team. It had like 20 to 30 people, but it was still one team. And that one team had their lead architect go to a conference that pitched microservices, which was a sad thing for this particular project. So what the architect decided to do was, of course, to separate everything into tiny little services. Services that were so small that they typically could be owned by a single person, right? So there were roughly maybe 30, 40 services for the 30 people in the team. So everyone could build their own thing, which felt good for the developers for a while. Now, the problem was, at some point in time, this had to scale. They had to bring in more developers. So what they ended up doing was they had these multiple teams that had access to a bunch of those services, but of course, as soon as they brought in more teams, they found out that these things actually overlapped, right? You actually ended up, if you wanted to build anything useful, competing about who got access to that particular microservice. So the initial assumption that one person could be responsible simply didn't hold anymore because of the team structure. The organization essentially ruined the initial architecture, which wasn't that great to begin with, but became much worse once they added more people to the whole thing. And one particular thing is so generic that I can now use this slide everywhere and claim it's a pattern, which is this particular thing here. It's the entity service anti-pattern. I think some of you have seen this. Actually, I can leave it like this because it's always the order service, right, in any system that has any sort of commerce, right? So you have this order service thing, which sounds like a good idea because it's kind of obvious, like it's an order, right? So you build something that manages orders. The problem with that is that you'll have a bunch of other services that will depend on this particular thing. So you'll end up having to manage those dependencies, which is essentially another word for architecture work, right? You'll have to manage those dependencies all the time. And the problem is that this particular order service isn't a generic thing. It actually has aspects of all of those things. So it does many things for many different people. There are aspects in an order that are related to fulfillment and aspects in an order that are related to support or to billing or to whatever. And if you aggregate all of them in this particular little entity thing, then you'll end up doing something that'll hurt you a lot. I think that it's now becoming known as a common anti-pattern. So if you find yourself building that, then maybe reflect on whether you're doing something good. Now, why does that happen? What's the reason people end up building those super fine-grained things? Anybody get a good guess? What's the main reason? Whose fault is it? Sorry? Oh, no. Does this help? So I totally admire this company, right? I'm a big fan of Netflix. I really am. I use their services all the time. I like them. Their architecture is really impressive, specifically in terms of operations and their usage of the cloud, their usage of AWS. It's absolutely fascinating. But almost nobody is Netflix, yet almost everybody copies their architecture, which is just a stupid idea. Unless you're building a scalable video platform for a few 100 million users running in 150 countries, then maybe you shouldn't be using the exact architecture that they have. Because it's probably not going to be a good match. Many companies end up with something like this, right? You have these you have this bunch of services, and then you have a monolithic application front end on top of that. That's actually what happened in this particular project. So what we actually ended up doing, or what not only we, the other teams as well, so we staffed a number of teams and other companies staffed other teams. What we ended up doing is we took this thing and we actually modularized it in the large and separated it into multiple instances. That's not great. I would like something else much better. But this was actually an improvement because now each of the teams owned their own little mess and could start improving upon it. But they didn't have those cross connections between teams when somebody had to access a service owned by somebody else, right? So this turned out to be more reasonably implemented like this, which meant that this could go. Right? So you refactor from the entity service pattern to something that actually makes the entities part of the teams and structures and architectural units that actually should own them. Right? So every time you violate that rule, you'll end up with a mess. So less and small is not always beautiful. Refactoring within team boundaries became much easier, right? Once they had this thing, they had a reasonably, maneuverable thing again. They had this little team that could actually do something on its own, or each of those teams could do something on its own and actually move the whole thing forward. And you can't ignore organizational parameters because that'll always hurt you no matter what you do. If you can't fix them, if you can't change them, then you have to adhere to the existing organization and try to make things work. Okay. My next case, it's actually another old one, but I love it so much I still have to talk to you about it. I call it Your System Will Be Dynamic because that's what happened here. This was an insurance company, a big system, actually life insurance, doesn't really matter, life insurance system. It used something called model-driven development. Those of you old enough to remember what that was, right? We used to generate a lot of code from models. They still do to this day. They have more than 100 developers, and that's because they don't actively develop a system anymore, they just maintain it. So it takes 100 people to maintain the whole thing, which is completely normal in the insurance industry. They manage 2 releases per year, so very modern, very agile. Now, something that they have and have had for a long time is this development process that actually lays out how this year is structured, right? You have all of those things that are going to happen at some point in time. And you can see that little thing here called modeling. That's actually a 2-week slot, once per half year, right? So every 6 months you have a 2-week slot where you can actually model something. That's because the model is maintained in a case tool. Again, the older ones of you will remember. Rational Rows, does anybody remember? It's been retired like 20 years ago. It's still very actively in use with them. Maintained in its own little VM of some Windows version that still runs it. So they have this modeling thing, and that's basically the only chance you have to make actual changes, right? Because everything's generated, all the data model stuff, all the connecting code that serializes objects through the network. So they have to do that in those 2 weeks. Now, what happens if you miss that slot, right? Well, you have to wait for at least 6 months if you're lucky, right? So if there's an important change that some business person wants, the developer will have to tell them, well, I can't do it, and then she'll have to find another way to do it. So what could we do? Well, we have this model, right? I mean, this is a big model. This is not as simple as mine here. It has like maybe 1,000 tables, and each of those tables has a ton of attributes. Now, we don't really need all of those attributes, do we? So if we have a requirement for something new, then maybe we can take a look at something that we don't need anymore and just change its meaning. And then we'll simply maintain a list of actual meanings of things, right? So the column that's called text code now actually means the region code until we change it and fix it with the next. That's just complete, utter madness. I'm sure everybody will agree, right? But it's the only way they could get this thing to work because it doesn't offer any sort of generic facility, anything that allows you to make those kinds of changes independently from the modeling phase. So they had to find a way to do that. And this, of course, was a complete nightmare, right? It was in actual practice because you had to maintain, this was an Excel file maintained by the person doing the modeling, right? So don't do that. My advice is don't copy this particular architecture. Centralized responsibility hurts. They had this centralized person who did the modeling, and that was the only chance to get it. It was in the process, not in the runtime, but it hurts you just as well, right? And you will always see people finding a way around those, finding a way around rules that are too rigid. I've seen this numerous times, like when it's too complicated to add a new method, right? If a new method has to be approved, or typically not a method, but let's say a remote call option, right? Like a a service or a service operation within some web service, if that has to be approved by somebody, pretty soon somebody will introduce an execute method, right? That'll be passed, what actually is supposed to be done as a parameter to that method. You'll always have ingenious developers who will find a way to get around those things. And one thing that really annoyed me a lot in this particular project was that everybody said or seemed to think this was completely okay, right? Because they were so used to it. Well, no, just because you're used to it doesn't make it suck less, right? It's still a very, very bad idea. So again, possibly don't do that. And while we're at it, in the same vein, I have this one, I call it Freestyle Architecture. And that is actually, from the opposite end, it's a very, very new project, very recent project, where people wanted to do everything in the right way and ended up doing things that hurt them a lot, even though they were well-intended. So, this was a very big online shop, a very large European retailer. They built everything new from scratch. Again, very big one, 100, 120 developers. And they had what they called self-contained teams. That's something I like a lot. The whole idea here is that you have teams that are autonomous, that can act on their own. They're self-contained, that actually maintain systems. Now, you might have seen me present a slide like this a few times. I need it for context. So I actually believe, and we actually believe, that if you increase the number of developers, which is something that you should avoid whenever you can, but if you have to increase the number of developers, then the method that you can use to get the desired kind of decoupling changes, right? You start with something that's built by a single person, then you don't need anything more than methods or procedures. And then you maybe go to some kind of module system, and then you maybe go to some kind of component model, if that's something you believe in. And then maybe you go to something like microservices, right? As the number of people increase, you need a better method to decouple things, a stronger boundary between those decoupled modules. And I strongly believe that at the end, at some level, you need different systems, right? It's such a sort of a logical conclusion of this idea, right? You'll end up with separate systems built by separate teams, because that's the strongest kind of isolation you can give them. They will communicate in much the same way that you would have an externally bought commercial off-the-shelf software communicate with something you built yourself. Right. So the idea here is that you go from something that everybody can draw, right? This kind of, draw me a diagram of your architecture, and somebody draws this, right? It's always the same diagram. Everybody can reuse this in every project they're ever tasked with doing architecture. Instead of this and then adding the modules on top of that, we essentially move to a system of systems where each of those systems might have some sort of layered architecture internally, might be a different one in the next system, whatever, it doesn't really matter. It's sort of a different view of the whole thing, right? It's building systems or doing system design first, and then looking at the individual systems. And this particular project team did a great job of that. I think they were really awesome, and they were really happy, and they actually have success stories about the whole thing. And I would typically tell you where you can find out more about them, but I'm going to talk badly about some of the stuff they did, so I won't. So the idea here in the end is, instead of that monolithic thing that I showed you before, you'll want to end up with something like this, right? Instead of having the monolithic thing having to integrate UI views over multiple services, you end up with something where each of those vertical slices owns its own UI, right? Each of the teams can build something end to end, and they can deploy something into production on their own. It's what people call self-contained systems. And the idea of such autonomous teams, I think, is a very good one. And that particular project, well, at least they claimed they couldn't have delivered the project at all if they hadn't followed this approach, because they would have never been able to get up to speed. But there were some things that really hurt them. The first one was that they didn't bother to standardize practically anything. They sort of exaggerated the autonomy aspect of the whole thing. So the integration of the user interface aspects from multiple teams was pretty much ad hoc, and it sucked. It didn't perform well at runtime, and it was hell to maintain. So it really hurt them a lot that they didn't have any sort of standard that somebody would have had to think about up front, right? Which was completely contrary to all of their views. They had the same thing on the middle layer, like vast differences in API style, API design, things like different formats for exchanging similar kind of information. Not talking about a canonical data model kind of madness, not at all, saying this, there's not much point in using, let's say, collection plus JSON and hell and siren, because you don't get any additional value from using everything that's out there, right? It makes a little sense to limit that a bit. And they also ended up, because they didn't have enough front-end people, with a centralized front-end team. And if you have a centralized front-end team, there will be a bottleneck in your runtime or development architecture. You can't avoid that. It's, again, the connection between organization and architecture. You'll end up with some people who are responsible for centralized aspects of your architecture. In this particular system, it happened so that there was a small team, that was the only team that knew how to efficiently build web UIs in terms of front-end performance optimization, like bundling things and minimizing and compressing stuff so that you can deliver something that's minimal so that the end user experience is good, which is a very, very valid goal. They only had the centralized team who could do that, who introduced a centralized tool chain for doing that and locked down the whole project every time they made an update of some kind. So the fact that they didn't decide on some architecture did not mean that they just avoided the work. It just meant that they ended up with an architecture they didn't want. Right? So if you ignore this completely, then you'll end up with something like this, right? They invested quite a bit into an architectural frame, not a framework, but an architectural set of rules called macro architecture, which is a very reasonable thing to do, but they didn't invest enough. And you'll have to do that to achieve this. I actually think there are a number of things related to this. One is that there is a fine line between diversity that adds value and chaos. Right? So having diversity in terms of the teams being able to do different things, I think is a value. If you have the maturity, then that's awesome, because a team can pick a best-of-breed solution for its own needs, and another team can innovate and try out something new, and then maybe tell the other teams about it, and they can copy it if it's cool, right? So it's good to have innovation, independence, and it's great that not everybody has to do the exact same thing. But you might end up with something where that doesn't add value. The format example was one. Another thing that I strongly believe is that if you want this extremely loose coupling between things, then you need extremely strict rules, which sounds a little stupid, but it's the rules that enforce the loose coupling that I'm talking about, right? You want to be able to rely on the fact that those things will never, let's say, have a direct database connection, or will never make direct method calls from one piece of code to the other, or they will not incorporate the same version of the same library or something like that, right? Those are all rules that you need to write down somewhere, because otherwise it's going to hurt you a lot. And I think there's sort of a quid pro quo deal here. You can talk or people can talk to each other, and the people who are tasked with maintaining the rules, whether you call them architect or lead developers or something else, or whether it's just a bunch of the most experienced developers from all the teams, whoever does that can make a deal with the rest and say, well, we will only have very, very few rules, but we will maintain them very strictly. And in return, you can do whatever you like as long as you don't violate them. We will not tell you how to format your code, or which library to use, or what exact framework or whatever it is you want to do, which many people still do as part of architecture work, which I'm completely opposed to. Okay. So, my next to last one, cancerous growth. I found this in a recent project, and I think it shows that if you are successful, you are at risk. Now, this is a very successful company I'm talking about. It's a financial service provider that has brokers as its clients, so it's sort of a long-tail market, very interesting company, provides great service to its users. Small, has like about 30 developers, and they really were able to build this because they knew the business domain, right? They were really good at the business logic aspect of the whole thing. They didn't really care about other things, and they have a lot of history. So it's a very successful company with a lot of history. And back then, 20 years ago, it might have been 25, they started out with something that, again, few people will remember, something called Oracle Forms. If you don't know what that is, that's very good for you. So there are many, no, I'm only joking. That was actually a very reasonable solution, number of 4GL tools, so that was just one of them, and it allowed normal people to build software, which is kind of cool. Now, what happened was that they found out at some point in time that this might not be the solution for the next century, because even though Oracle still maintains support for the thing, they still don't want to do that anymore. So they added and moved to a JavaScript web app and maintained the business logic within the Oracle DB, right? That's now, again, that's not in itself bad. I mean, a bit maybe, but you can build a maintainable system with those kinds of things, but typically you don't. Now, they had this on top, and they thought this was interesting, but not interesting enough. So they added a number of web services back when you liked web services, and they built them in C#, because why not, right? So they added a bit to the mix. I had now a Java-based front end, .NET or C# as a web service implementation language, and that was sort of okay for a number of years. And then they bought another company. That other company had a completely different IT, and they thought about adopting that, but they decided not to. They decided to move the other company onto their existing system. Okay, why not? They also found out that they couldn't, because it was different. So of course they copied the system, and now had two of those, right? And so they maintained the differences in the code, so any change had to be done twice. But that was okay, because they had the brilliant idea to centralize the database, right? So they decided to make the data model the superset of all the things in both companies, and then have the code sit on top of that whole thing. Now that became a really, really interesting challenge, and you can keep a whole number of developers busy without adding any business value, just by maintaining that particular thing. Now, over the course of the next 2 years, this thing grew. As you may have noticed, people sort of like adding tools, so they added a number of databases. I only could fit 5 in here with that size, so it's actually 8, I think. So if there's a database, they have it somewhere, and they typically have it twice or once with the merged data model from both companies. And one of my favorite stories is, I couldn't fit that anywhere, so I put it up there. They have this little C++ encryption lib because they decided it's a great idea to implement their own encryption algorithm. So they took a standard, they didn't invent a new algorithm, they just implemented an existing algorithm, which is an idea that's almost as bad as building your own algorithm. So they implemented this algorithm, and of course they made an error implementing it. And when they found the error, they already had encrypted a lot of data. So they now can't switch the broken one for the real one, because then they would no longer be able to decrypt the data. So they're going to be stuck with this particular thing. It's written in Borland C++, and it runs in a Windows VM. Yeah. So those things happen. Nobody wants them, right? Those things happen to you. I think sometimes it's that successful systems end up with the worst kind of architecture. That's kind of weird, right? It's because nobody ever invests in architecture, because nobody really cares about it, because they're successful, right? I mean, why would they? Until at some point in time, it feels like they're a burning oil platform that's still getting oil from the earth, right? Somewhere in the ocean. It sits there, and everybody's happily producing oil. Yeah, at some point in time, they start then to try to figure out how to do this. So it's better to start earlier with those efforts, as opposed to waiting until you find out at some point in time. Unmanaged evolution will lead to complete chaos, right? It's just the entropy, right? You have to manage it somehow. You have carefully, don't be afraid of some architectural governance. I know I said it at the beginning, architecture is sometimes a swear word to some people, but a little bit of it doesn't really hurt you. Right? And maybe you should do that. Now here's my last one. It's slightly more positive, right? That's actually an improvement that I think is interesting, because the new thing does less than the old thing. And I think that's a rare situation. So the context here is a bank with multiple commercial off-the-shelf systems. So it's basically an integration scenario. And this particular bank had an existing solution, which was built by a very large vendor that's typically colored blue. So a very large solution that was phased out, right? And it was highly proprietary. And they basically just had 3 or 4 people in the world who still knew how this particular version of that system worked, and they had managed to keep things running. They still managed to keep parts of it running for a long time, but they knew they had to do something else. So what they wanted to do initially was replace the commercial product with some open source solution, because the decision for the commercial product had been made like 15 years ago, and they knew that there were now really cool things out in the market. So they decided to look for something. They actually hired us to help them look for something, and we built a new system for them. So what they had was this message broker thing, right? This piece of magic that was super configurable, that had its own IDE. It's always a bad sign. If a tool brings its own IDE, you should be worried. So it had its own user interface, and it did a lot of things, right? Like this is sort of the feature list of integration products, right? You have all of those things. The last thing should worry you a lot, right? Because business logic really does not belong in such an integration solution, but it always ends up being there once you have something that's capable of doing that. So what happened was they actually built business logic using the configuration language of the particular tool, which included a visual mapping thing that could map one XML structure to another. Now, that's not something that you can unit test, right? Or that's not software development. That's just a disaster. So again, I'm ranting. I didn't want to do that. So what we replaced it with was something that looked a lot more like this. So there was a messaging solution in the middle, but it was a really, really small one. And had these little things that now stick close to the individual things, which the team called adapters. And those adapters did a lot of the things that the original platform did within the Magic integration platform, right? So they decided to move things to those adapters. And those adapters had a completely different architecture. They used a fancy concept called programming. So if you wanted to do something, you wrote a program. And they actually ended up configuring, because there was a Java shop, they configured a very small tool stack based on Apache Camel to actually show them how they can write something like this, but they only ever intended it to be taken as a blueprint. This is an example of how you could do it in one of those adapters. But don't assume that there's a centralized instance of that, right? So the centralized instance here really did what a pub/sub messaging system does, right? It had topics, and you could subscribe to a topic, and it did some error handling, and it did some transport, reliable transport, and delivery, and stuff like that, right? So there was I think it was RabbitMQ, doesn't really matter. It was a standard messaging solution, which worked for them. And then the adapters were those little programs, and they were essentially Dockerized. So they had a little Docker Swarm-based runtime that could run those things, and that's it. If you want to build something, if you want to integrate something, you didn't fire up an IDE with a GUI that allowed you to do the work that you could program in 10 minutes in 3 hours. You just did the 10-minute work and wrote a script or a little Java program. Right? So, and I like that solution a lot because it helped them replace a lot of what the existing system does. They're still both running, so they've moved, I think, about half of the load of the old system. They're going to slowly move it within the next 3 years, sort of a strangler pattern, if you know what that is. Very slowly suffocating the old system and then finally switching over to the new one. And that, I think, is a very good example of something that was good enough for this particular scenario. Okay, so I've said most of those. Smart endpoints, dumb pipes, that quote was originally by Jim Weber, I think is a very, very good thing. Never put too much logic and too much intelligence into your infrastructure. I know it's very tempting, but it doesn't matter how cool the name is. Even if it's a service mesh, something that I like, right? It's still a very stupid idea to give it too much power and to risk ending up having to maintain it as the piece where logic resides. There's a lot of value of specific over generic solutions, right? Sometimes you end up with something that's much better if you just implement something that's not as sophisticated, not as generic, right? And I like this microarchitecture with blueprints idea because I think it'll give you a lot of opportunity for showing people how to do something that they can get to speed very quickly, but you don't impose something that'll be enforced all the time for everyone, because that does not make sense, right? Think of this adapter scenario. There are certain adapters for certain systems that are probably much better written in C# or maybe VB.NET if it's a Microsoft platform-based product that they have. Might make a lot more sense. So why would you force some poor Microsoft developer to use Apache Camel? Right. Or the other way around. I don't really care. Okay, so here are my takeaways, and then we can discuss a bit. My first one is don't be afraid of architecture. I think it's perfectly reasonable, perfectly fine to make architecture something that is discussed and that should be pragmatic and that should be reasonable, right? I'm not talking about the traditional kind of, we fill shelves with folders with paper that nobody ever reads. Don't do that unless you're on a government contract, because then you have to. Well, not even that. Choose the simplest thing that'll work, right? Choose something that will fulfill the needs and be pragmatic about the whole thing. Right? But also think that this stuff might need to evolve, right? And that if that sounds like something that's in conflict, that's because it is, right? This whole, it really depends on who you talk to. If you talk to a group of people who never take any risks and who never think of, well, we might have to do this next year, so let's build things this way now so that we don't have as much work next year. Of course, that's a risk because you're gambling that this particular thing is going to occur. Of course, you can say, well, let's not do that. Let's just build the stuff that we need today. But then you'll have to pay for adapting that later. So the Yagni principle does not mean don't ever think again, right? Make a good and conscious decision between those two things, choosing the simplest thing that will work and creating evolvable structures. And once you've done that, manage your system's evolution. Architecture is not something you can do up front. Your architecture will most likely suck, and you will only find out after a year. And that's fine, because then you change it so that it doesn't suck anymore. And that's just part of architectural work, right? You have to change your architecture within the possibilities that it originally gave you. That's why I'm a big fan of architectures that have this evolvability built in, right? Where you build something that from scratch is designed in a way that you can change a lot of decisions without risking the whole the structure of the whole thing. And if you are tasked with an architecture role, with an architect's role, if that's on your business card, then do something of value, right? Don't create roadblocks. That's not your goal to, force your personal taste on everybody else in the company. Just, do meaningful, valuable work and get out of the way as fast as you can. And that's all I have. Thanks a lot.